Welcome everybody. This video is going to contain two different examples for the starting points 3 and 4 for non-right triangles. These are the two that will use the cosine law to start. You have a little bit of flexibility after you get your first step done, but these two need the cosine law because we won't be starting with an angle and opposite side pair, which would normally mean we could use the sine law. So if we can't use the sine law, the cosine law is the only option. So we're going to start with one here where we have all three sides. So if we have no angles, we can't have any angle and side pairs. So we have to right away get into the cosine law to solve one of the angles. Now in class, we did discuss which is the best angle to solve for. In this case, it would be angle A because side A is 42 inches. That is the longest side, so we'll have the largest angle at A. And remember, the issue is if we want to get into the sine law later, because it's a little bit of an easier formula, we do need to be careful with the calculator error that shows up there. If an angle is bigger than 90 degrees, then your calculator doesn't actually give you that angle when you type in the sine. It'll give you the less than 90 degree version that has the same sine value. So if we target the largest angle first, that basically marks the other two angles as safe because they will definitely be less than 90 degrees. So let's start with that. So the cosine law for A would be using this formula here. A squared is equal to B squared plus C squared minus 2BC cos A. So A shows up on the left side, A squared, and then there's a single A in the angle over there. You would have these on a formula sheet if you had a quiz, but remember that we do need to rearrange this one, and that is not something that's provided for you. So we'll go through the rearranging steps again here. What we want to do is basically swap these two terms. We want the cos A term, but right now it has a negative in front with that minus 2BC being times in front of it. So we're going to swap these two around. So this is going to become a plus 2BC cos A, and this is going to become a minus A squared as they go over the equal sign. So we'll end up with 2BC cos A is equal to B squared plus C squared minus A squared. And then to get rid of or to isolate for just the cos A, we need to remove the multiplication in front. So to remove multiplication, it has to be division, because that's the opposite of multiplying. Just remember that 2BC is timesing with cosine of A. It's not adding, so you can't subtract. You cannot subtract 2BC to cancel it out. That would be starting with the incorrect formula. So these would cancel out here, and we would get that cosine of A is equal to B squared plus C squared minus A squared, all divided by 2BC. So if you're rearranging any of the different formulas for angle B or angle C with the cosine law, it follows the exact same sort of structure. Again, the A only shows up twice. It shows up once in the angle, and it's always the subtraction one on the squared. So you can recognize this pattern to kind of get the hang of things, to make sure you've rearranged it correctly. Now, this is still a somewhat difficult formula to evaluate, especially if you just try to type it in all at once in your calculator, because this fraction notation is hiding some brackets. So I'm going to solve this kind of a little bit more basically, where I evaluate the top, evaluate the bottom, divide last. So I'm going to be doing some separate steps, and I'll be using Desmos, the scientific calculator, here on the side. It does show me a history, so it kind of takes care of some of the writing down of the information for me. So I'm going to take advantage of that. Okay, let's start by solving for angle A. So subbing in, we're going to get that cosine of A is equal to B squared, which was 42 and 1/16 of an inch. So we do need to put that in as a decimal. 42 plus 1/16. Let's put that into the calculator. So that's 42.0625. That's going to get squared plus C squared, which is 32 3/4. That's 32.75 as a decimal. Then minus A squared, which is the 42 and, whoops, I put that in the wrong order. This was third. it was c squared that needed to be added first. Yeah, so the order of a and b squared doesn't matter here since they're adding together, but we need 29 3/8. So that's 29.375. So b squared plus c squared minus a squared, all divided by 2 times 29.375 and 32.75. Okay, so again, all in your calculator all at once. It's a little bit tricky. So I'm going to solve the top first. So just computing at top, we're going to get, let's just get a new line here in the calculator, 29.375 squared plus 32.75 squared minus 42.0625 squared. So that all works out to 166.199. So I'm just going to let Desmos keep track of that number, and I won't write it down here. And the bottom part is 2 times 29.375 times 32.75, and that's 1,924.06. So since we're dealing with cosine, we should be seeing a value usually less than 1, so it's usually a decimal. If the angle is bigger than 90 degrees, you will see a value that is, no, they're all still going to be less than 1. Never mind, scratch that. You'll actually see a negative value, I think, if it's over 90 degrees. So getting a negative value at this evaluation stage isn't the end of the world, so that's one thing to just clue in. I know it would be maybe a little bit causing some questions, but a negative value is okay for these for the cosine at this point. All right, so let's put this in. So cosine of A is going to be equal to the top, which was 166.199. I'm just keeping some of the decimals here. I'm not being super rigid with how many I take, but I'm just trying to avoid some rounding error. Okay, so this gets me a decimal of, let's see, 166.199 divided by 0. Well, that's not what I was supposed to be doing. Where's my delete? 1924.06. So the decimal there is 0.08637,638. So this is what I want to put into the calculator. I'm going to do that here just to save some space. Going down. So cosine, but shift cosine or cosine inverse, cos to the -1 of 0.08638. And so I'm going to find that cosine inverse of 0.08638. So this looks like it's an 85-degree angle. I'm going to put 85.0. I'll take 1 decimal point. All right, so that gives us our first piece of information, and this is now the largest angle inside of the triangle. So angles B and C have to be smaller than this one, and that kind of guarantees that the sine law isn't going to cause a problem. And again, it's the calculator that is the problem. It doesn't give us angles from sine that are larger than 90 degrees. So now we're in the clear here. So I'm going to switch to the sine law, although if you wanted to, you could use the different versions of the formula for cos B and cos C and just do 3 identical operations here. If you find that simpler, go ahead and do that. You should get the same answers. You might find a slight difference in rounding if you do a different method, but the answers will be the same. So I'm going to switch into the other one now, though. So now we have an angle and side pair with A and A. So we'll use that to kind of pivot on our other information. So I'm going to go in and let's hit enter on the calculator here. So I would be looking for, doesn't matter which angle is next, so I'm just going to go for angle B. Next we're going to go for, maybe we'll draw a little divider here. We'll say that sine of B divided by B, which was the 29.375. And then we're using our angle and side pair, so sine of 85 0 degrees. And side A was the 42.0625. And I might as well set up the other one because it's an identical calculation. Or actually, it's going to be 180 degrees minus the angle B. So never mind, changed my mind. We could use the sine law for angle C as well, but it's easier if we're going the fastest way. We'll do it this way. So I've got my variable in the top, which is good. So all I need to do is times away. We're going to times both sides by the 29.375. So that's going to cancel it out, and we'll get the sine B value. And again, with sines, they're usually a decimal less than 1. So that's what we're hoping to see there if we don't have an evaluation error. So I'm going to put that into the calculator on the side here. So sine of 85, I'm just going to have my brackets there. So then times 29.375, then divide by 42.0625. Now, the way this is showing up in Desmos, where it's sine 85 times the fraction, sine 85 would times into the numerator of the fraction. So even though it looks a little bit different, this is the same calculation, in case you thought I was doing something a little different. So the decimal here is 0.697, 57. So that's kind of what we're expecting, a decimal less than 1. So I'm going to press enter on the calculator and then do the shift sign of 0.6957. And that's going to be let's hit enter. So B is going to be a 44.1 degree angle. So now we've got two angles here, and angle C is going to be 180 degrees minus those two. So 85.0 and 44.1. So that's a little faster than using the sine law a second time. So we are kind of choosing which tool is the quickest. Like I said, you could do 3 versions of the cosine law to solve this problem. There's nothing wrong with that. But in terms of how much work I'm writing down, the first step took the most writing. So you would just be committing to maybe a longer solution, but it's still absolutely fine. So minus 85 minus 44.1. So the last angle there is 50.9 degrees. So that would finish this one up here, because now we've got all 3 angles and all 3 sides. We started with all 3 sides. So this triangle is now done. So overall, we're using our same tools here. The only thing you got to be careful with, because there is the potential of getting an incorrect answer in some special cases, where if you've got a triangle that has a larger than 90 degree angle, or otherwise known as an obtuse angle, if you leave that for like the sine law steps at the end, then your calculator does give you that incorrect answer. So you do need to work around your calculator's kind of deficiencies. So just in this one, just make sure you solve for the largest angle first with that cosine law. So find your largest side and use that to find the largest angle. Then everything else works out much more easily. Okay, so I'm going to move into the next one. If you want to take a look at this solution, maybe just pause the video now, and then you can kind of get caught up. All right, so next page here, we'll get our next triangle up. So I'll draw another placeholder diagram for this triangle. Oops, let's get it to make it improve my handwriting. There we go. So again, this is a placeholder triangle. This is not to scale, but I am labeling the sides with that opposite angle and side notation, and that is super important for all of these questions. So the other starting point here is, we've kind of seen this one before. Starting point number 4 is when you have 2 sides and 1 angle again, which we actually saw with the sine law. That was starting point number 2. But here we have to realize that there is no opposite side pair, opposite side angle pair. Okay, because when we did starting point number 2, I said measure grab a triangle, measure one of the angles, and measure its opposite side. I purposely said you have to make sure you measure the opposite side there, and that would help us lead into a sine law question. Now, if we purposely don't include the opposite side and angle pair, that actually forces us into the cosine law. So there is a similarity in the starting point here with two sides and one angle. It's the same kinds of information, but where they are placed in the triangle makes it different. So we are going to start with side B is going to be 21 inches and an eighth. And we're going to have angle A, which is 39 degrees. And we're going to have side C, which is 31 and a half inches. So how this information looks, I'm just going to put a circle around these ones. What I find this ends up looking like is you're actually targeting A when you work out the cosine law and what it is we're solving for. I find this tends to look like, I don't know, I find it looks like a slingshot to me, and it kind of shoots toward the unknown side A. So yeah, for some reason that just sticks with me all the time. It's like a slingshot orientation and we're solving for that opposite side, and that's kind of a cosine law setup. So if you're drawing your triangles and you also resonate with this visual of a slingshot, then that's one way to kind of memorably clue into that we need to start with the cosine law here. So there's no kind of flexibility on what we're doing as the first step, so we're just going to get in and do it. And we have to just kind of evaluate this formula, but be careful because similar to the Pythagorean theorem, we're solving for a squared. So we are going to end with a square root. But let's get the formula in here. So it's a squared plus b is equal to b squared plus c squared minus 2bc cosine of a again. But we don't need to rearrange this one. We just need to substitute in. So a squared, I'll leave a little bit of space here. B squared is 21 and an eighth. So that's 21.125. That's what the eighth contributes. As a decimal, the C is 31.5 because it's a half. And then minus 2bc, 0.125. Just going to have to be careful with room here. Haven't left myself quite enough. And then, so I'm just going to write the cosine of 39 underneath here. Actually, I can do one better since I'm not on the whiteboard. I'll just move this all over a little bit. There we go. Now there's room, magically. Okay, so cosine of 39 degrees is going to be a decimal, so we can put that into the calculator. And just remember, it's timesing with the 2, the 21.25, and the 31.5. In terms of putting this into your calculator, it's not super difficult in terms of order of operations. What you see is basically what you get. You don't need to worry about like hidden brackets because of a fraction notation. So I'm just going to put this all in at once. So 21.125 squared plus 31.5 squared minus 2 times 21.125 times, you could use brackets here if you like to do that in the calculator, and then times cosine of 39 degrees. I'm just going to point out here that I do have the Desmos calculator in degree mode here. So if you were struggling with decimals from the calculator last question, do check over your calculator. So remember, this is a squared here. So a squared is equal to 404.23. We'll just leave it like that. And this is technically inches squared. I'm going to leave the units off right now. But a is going to be equal to the square root of this, because 404 for the side of a triangle, when the other sides are 31 and 21 inches, is way too big. So a is going to be equal to, let's just get that square root, 404.23. I guess we didn't need a bracket there. Oh well. Desmos is fixing it for me. So it's 20.105. Let's get 4 decimal places if we're trying to get to the nearest 16th. So 1055. and this is in inches. So I'm going to convert this. So I just want the decimal point here. So I'm just going to take the 0.1055, and I'm going to times that by 16 to get the numerator of the fraction, what is the nearest 16th of an inch. So 0.1055 times 16. This is 1.66, or 1.69, not 66. So that's going to round to 2. So that means we're dealing with 20 inches and 2/16. But that's going to round to, or reduce is a better word, or accurate word. That's going to be an eighth. So 20 and an eighth inches is going to be side A. So now we've got 3 sides and 1 angle. So 2 angles left to solve for. I'm just going to write the 20 and 1/8 up here. So at this point, we do still want to pay attention to the angles we have left in the triangle. With angle A being 39 degrees, there's still like 141 degrees up for grabs in this triangle because all the angles need to total up to 180. So that means the odds of one of them being larger than 90 when there's 141 degrees, up for grabs, it's still pretty decent there. So we have to be careful with what angle we solve for next. So just like in the last question where we targeted the largest angle, which is opposite the largest side, with the cosine law, because that one didn't have an issue in the calculator. Now we want to use the sine law because it's, again, faster than the cosine law, but we know that it doesn't work, it's going to have a problem if I target the larger angle. So it would be nice if I could already know which was the smaller of the 2 angles, because that's definitely going to be safe, right? There's only ever one angle in a triangle that could be larger than 90 degrees. So if I knew which was smaller between B or C, then I could just go for the smaller angle here. And if you remember that relationship between the angles and the sides, what we're looking for then is out of the remaining angles, B or C, we want to take a look at the opposite sides. Side B is 21 and an eighth. Side C is 31 and a half inches. So the smaller angle is going to have a smaller opposite side. So that means we would solve for B. So I'm going to just write a note here. Solve for B since B is less than C. It has a smaller opposite side. So that means angle B is going to be smaller, and going, again, the fastest I can, the shortest amount of work. I want to use the sine law because it's a simpler formula, and I'm going to go for side B. So we'll set up the sine law, and we're putting the sides in the top, because again, you want your variables in the top of these fractions. So B over sine of B, which is the thing, or no, we're going for angles. We have side B. So switch, I'm going to put sine of B in the top, and B, side B is 21 and an eighth, which is the 21.125. And we're going to compare that to our now angle side pair because we have both A's. So it's sine of 39 degrees divided by 20 and an eighth, which is the same, 20.125. So just kind of predicting here, since those sides are very similar with the 21.125 and 21.25, we should predict that angle B should be pretty close to 39 here. But let's go through the solving again. Since we've made sure that our variables in the top, we just need to times away the denominator on both sides. So we're going to be timesing both sides by 21.125. So that's going to cancel on the left, which is what we want because we want to isolate for the sine of B. So sine of B is going to be equal to this decimal of sine of 39 degrees times 21.25. That's in the numerator. Then divide by 20.125. So I'm just going to do that right in the calculator here. So sine of 39 degrees, close the bracket, because I don't want that to be, I don't want the times 21 to be included in the angle, times by 21.125 and divided by 20.125. So the decimal here we're getting is 0.7 0.6606. So when I do my shift sign, or whatever you want to call it here, of the decimal, so shift sign of 0.6606, we're getting that is a 41.3 degree angle. So let's just write one extra line, B's, then 41.3 degrees. And remember, we said from the equation, since those side lengths were so similar, we should see about a 39 degree angle. 41.3 kind of checks out there. So if you are kind of looking at your values and guessing what your answer is going to be, this is all in line with what we were expecting. So confidence is then running high. So now, what do we have left in this triangle? We've got angle B now is 41.3. So we've got all the sides. We're just missing the final angle, which is C. And it's always easiest at this point to say that C is equal to 180 degrees minus 41.3 minus 39 degrees. So we're avoiding, again, the sine law for this last angle. I don't think it's going to be over 90 degrees here. Oh, no, actually, it is going to be a little bit over. So C is going to be equal to, let's just put this in the calculator. Press enter on the last line. 180 minus 41.3 minus 39, 99.7. So we would have gotten an error if we had solved for angle C first with the sine law. So C is equal to 99.7. Okay, so just to kind of highlight there, the angle we know is 99.7, but remember that exercise we had in the calculator where if we take sine of 99.7, we get this sine value of 0.9857, right? But then if we were to, this is the decimal we would have gotten if we were to start the sine law, but solving for angle C. But when we go ahead and try to ask the calculator, what is the angle, if this is the decimal, so 0.9857, it would have given us an 80 degree angle. So it's prioritizing the quadrant 1, the less than 90 degree solution, but that's not what we have here. Remember, so that is like legitimately a calculator error, and we have to make sure we avoid that when we're dealing with these non-right triangles. So 99.7 degrees is correct here. If we were to, say, at this point, switch to the cosine law, which doesn't have that calculator error, it wouldn't give us the 80 degree angle. It would give us the 99.7 degrees. So if you're confused at why it's not 80.3, the sine is the only one that's giving us that answer. If we use the cosine law or this 180 degree rule, then we're getting 99.7. It is the sine that is the problem here. Okay, so at this point, I'll just zoom out so you can maybe pause this frame if you want to see the full solution, but we do have everything here. So there is a little bit of solving in a particular order here because of the sine law, because we want to use it, but it does have that calculator issue. So the trick here is once you have your third side, with the two remaining angles that are there, just target the smaller one. So look for the smaller of the two opposite sides and then find its corresponding angle. As long as you find that strategy, as long as you follow that strategy, you won't ever get an error issue, or you won't ever get an incorrect value from following this workflow. Okay, so we're gonna stop the video here, and good luck practicing.